Okay, here we have a question that says, let me see, we have waypoint 1, 60 south 30 west, and waypoint 2, 60 south 20 west. They've been inserted into an INS connected to an autopilot, and the question is, what will be the approximate latitude shown on display at longitude 25 west? So I'm just going to draw up the scenario. The scenario looks like this. So this would be 60 south, and we would have 20 west, 30 west, and waypoint 1 is here, here, and this would be waypoint 2. All right, and we have, since it's a autopilot flying, we are assuming in this question that we would be flying a great circle track. And the great circle track would be looking like this somehow. Since it's on the southern hemisphere, the great circle track is concave to the equator, convex to the south pole. So this would be the great circle track. Okay, and it's going from waypoint 1 in this direction. Okay. So let's have a better look on the question. Here you can see that the question is asking us, what will be the approximate latitude shown on the display at longitude 25 west? The approximate latitude shown when we are crossing 25 west. 25 west would be midway between, and we are looking for what will be the latitude that we will be reaching here. Okay, what would be the southernmost latitude that we will reach? Okay, so first thing that we do is we want to calculate the conversion angle. We want to calculate the angle between the rump line, which is here, and the great circle, which is here. Okay? The rump line is, in this direction, would be rump line 90. And we want to know the great circle track here from waypoint 1. So we do that by calculating as follows. Conversion angle is equal to half the convergence, which is calculated by d long, multiplied by sine of the latitude. And that's 0.5 multiplied by d long, which is between those two here, which is 10 degrees, multiplied by sine of 60, that would be this latitude here. The conversion angle will therefore be, as I calculate, 4.33 degrees. That would be this angle here, 4.33 degrees. So the rump line, the great circle through here would be 94.33 degrees. All right. Now, what we're going to look for here, because we are looking for the latitude we're reaching, we need to add in another thought. We need to see that, we need to realize that at this point, the great circle and the rump line are parallel. So the great circle at this point will be 90 degrees in this direction. So it has changed from 94.33 to 90 degrees. Okay, so we can see that the average great circle track from this location here to this location here is 94.33 plus 90 equals to 184.33 divided by 2 to get the average. So the average great circle track will be 92 0.165 degrees. That would be the average great circle track for this complete leg here. All right. So now we can treat this as a 1 in 60 question. We can say that the angle 92.165, we have an additional angle here, therefore, of 2 degrees 0.165. All right. So we have distance off, distance gone, and the z. And the 1 in 60 calculation was z equals to distance off divided by distance gone multiplied by 60. So we have the z. We have the z being 2.165. 2.165 equals to distance off, which is the unknown factor. We don't know this length here. So it will be x. And we need to know this distance here, which will be easily calculated as this being the 5 degrees from 30 to 25. We need to do the departure formula for that. And that is done the following way. Departure in nautical miles equals to d long in minutes multiplied by cos of the lat. Okay, so d long in minutes is 5 times 60 to get the degrees into minutes, or 300 minutes. Multiplied by cos of 60, since it's on latitude 60. It's departure 150 nautical miles. So that gives us 150 nautical miles here. So we have therefore the distance gone 150 multiplied by 60. And we need to twist this formula to isolate the x. The x equals to 2.165 multiplied by 150 divided by 60. The x is equal to 5.4 in this case, degrees. No, sorry, not degrees, nautical miles. Okay, so 5.4 nautical miles. All right, so now let's have a look at this case here. 5.4 nautical miles. We know that it's a latitude. 1 minute, well, we can say what? 1 degree is 60 minutes. 1 degree is 60 nautical miles. Therefore, 1 minute is 1 nautical mile. Therefore, 5.4 nautical miles is 5.4 minutes, isn't it? So, in fact, this latitude, therefore, would be 60 degrees south, 5.4 minutes south. So in some questions in the question bank, the nearest answer, as I've seen, would be, the closest answer would be 60 degrees, 6 minutes south, and that probably would be your final result. I've seen this question on the question box, and the question number is the question number is 40867, if it doesn't matter. Anyhow, I hope you enjoyed. Thank you, and remember to subscribe.